following webinar is the second webinar in a series of 5 covering the topic of managing exposure to hand-arm vibration. In this second webinar, we'll be covering the topic of how to assess exposure to hand-arm vibration, i.e. assessing the risk. From this webinar, you should expect to gain an understanding of the elements involved in assessing exposure to hand-arm vibration. You should be able to understand the HSE exposure point system and the associated thresholds. Gain an understanding of what to do following a risk assessment and have understood the variables that come into play when assessing exposure to hand-arm vibration. Before going into the topic in detail, the following graphic has been provided to illustrate the diversity of work which can lead to individuals being exposed to levels of hand-arm vibration which can cause the disease hand-arm vibration syndrome, as these are the number of people who have been reported to both the HSE and ORR over a 5-year period from 2014 to 2018 who are showing symptoms of the disease hand-arm vibration syndrome and have therefore been exposed to dangerous levels of hand-arm vibration. The requirement to carry out a risk assessment of exposure to hand-arm vibration comes from the Control of Vibration at Work Regulations 2005. These regulations require that employers should either eliminate or control to at least low a level as reasonably practical exposure to hand-arm vibration. The regulations require that an assessment should be carried out of an individual's exposure such that their daily exposure to vibration is understood. The regulations also require that those who are exposed to that risk should be provided with information, instruction and training on the risk from exposure to vibration. As with any risk assessment, the purpose of an assessment is to enable the management of the risk. So an assessment would be deemed adequate if it provided enough information to enable you to take the most appropriate action, and thereby to target the exposures which are giving the highest risk and therefore the biggest gains when those risks can be addressed to reduce the risk as low as reasonably practicable. Turning on specifically to hand-arm vibration, a key part of the assessment is the evaluation of the exposure. That requires that you identify where there might be a risk from vibration and who it is that is affected by that risk. Your evaluation should contain a reasonable estimate of your employee's exposure. Reasonable estimate here is emphasised, and I think it will become clear in the following slides why is the case that your estimate could only ever be regarded as reasonable. Your evaluation should allow you to understand what you need to do to comply with the law. That is, whether you need control measures on the vibration levels, and if so, where and what type they should be. It should also allow you to identify which of your employees should be then provided with health surveillance. So for each worker or task, you first of all need to decide what needs to be assessed. So for the tools, consider the operating modes and the accessories to be applied to the tool. For the tool user, consider their posture, the force which they're using the tool, but also their environment. For example, low temperatures introduce heightened risk in exposure to hand-arm vibration. Other human factors to be considered include their experience in using the tool and also whether perhaps they're tired. You need to take account of the machines or the tools that are being used, but also the materials that's to be worked by the tool. It's advisable to observe the process first, and from that you will be in a better position to decide on your approach to the risk assessment. Also, given all the variables that can exist, you need to ensure that your assessment is typical of the future work that you're trying to assess. And also give consideration to what tools might be available to actually help you with carrying out your assessment. The HSE have developed a point system to aid the process of quantifying exposure to hand-arm vibration. Exposure to hand-arm vibration is quantified by combining the time of the exposure and the vibration magnitude or energy experienced during the exposure. And what the point system does is it allows you to combine the risk of using multiple tools together in quite a simple way, because you can simply add the individual risk elements together. It converts the more traditional quantifying method, which is described as A8s, which is essentially the equivalent vibration magnitude for a period of 8 hours expressed in meters per second squared, and A8s. To give you some idea of quantification, exposure to 100 points in the point system is known as the exposure action value and is equivalent to using a tool with a vibration magnitude of 2.5 meters per second squared for 8 hours. 400 points, which is known as the exposure limit value, is equivalent to using a tool with 5 meters per second squared magnitude for a period of 8 hours. Exposure points can be developed from any combination of time and vibration magnitude. There is a ready reckoner available from the HSE on their website, which shows you graphically how these two variables can be combined. On the left-hand scale is vibration magnitude in meters per second squared, and on the horizontal scale is the exposure time expressed in minutes and hours. So in the example shown for the angle grinder, which has a vibration magnitude of 5 meters per second squared, if you wanted to know the exposure in using this tool for 3 hours, you would follow the arrows on the scale and it shows an exposure reading of 150 points. On the website, the HSE also have an exposure calculator, which allows you to combine multiple tasks and provide the exposure points. And what you can see is actually provides a drop-down box from which you can select a number of different typical tools. And if you select from the HSE's group of tools, it will provide you with a typical vibration magnitude that they would expect for that tool in meters per second squared. From that vibration magnitude, the HSE will then provide you with the exposure points per hour for that vibration magnitude. It will then also advise the time that it would take using a tool of that vibration magnitude to achieve, first of all, the exposure action value, which you can see here is showing in the A8 scheme, so an A8 of 2.5 meters per second squared. It also shows you the time that it would take in hours and minutes to reach the exposure limit value. Again, the limit value is expressed in A8 terms here. If you were to know the time that you expected to use this tool, so in this instance here, someone has entered 1 hour and 15 minutes, it shows you in A8 values that the exposure level reached is 1.5, and in the point system, which is the simpler system to use, it's 490. So to explain why the point system is easier, there's a second tool being entered here, a demolition hammer, again, typical vibration data provided by the HSE. This is to be used for 30 minutes, and that will yield a risk of 324 points. So if both these activities were to be carried out in one day, the person would be exposed to 814 points, which you can see is the simple addition of these two numbers. By contrast, in the A8 scheme, the risk from the first activity is 5.5, from the second activity is 4.5, and the combination of those two activities is 7.1, which is actually the square root of the sum of the squares of these two activities, so a much more mathematically complex arrangement. The numbering point system is a much more simple way to combine risk from different activities. So just to explain a little further on the exposure thresholds. So first of all, the exposure action value, which is expressed as either 2.5 meters squared in A8 terms, or much more simply as 100 points. If exposure is deemed to exceed 100 points, then there is a legal requirement to put in a program of measures or controls to reduce that risk. There is also a requirement to ensure that the employee has access to a health surveillance program. The exposure limit value, which is 400 points, legally, no one should be exposed to a risk that exceeds the exposure limit value of 400 points. If someone is assessed to have reached this level of exposure, immediate action should be taken to prevent reoccurrence. So having established that two parameters are needed for assessing exposure to hand-arm vibration, that being the time of exposure and the vibration magnitude during exposure, I'm going to look at the topic of the vibration magnitude. In their L140 guidance, the HSE quote 5 possible sources of data for vibration magnitude. The information declared by the tool manufacturer, databases such as the one available from OPERC, specialist consultants who may provide this type of data, trade associations such as and government agencies such as the HSE. In fact, the HSE have a very helpful Appendix 3 document, which has a lot of typical data for tools. And then lastly, workplace measurements, where tools are actually measured in the workplace. No matter the source of vibration magnitude, the most important thing is to take the time to establish that that vibration magnitude is reflecting the work that you are trying to assess in your risk assessment. Is it representative? And legally, is it probably the vibration magnitude that will be faced while doing the work that you are trying to assess? I'm going to look at next what the HSE would consider to not be a risk assessment, which many companies may actually currently do in the manner shown here. What we're looking at here is results from measurements of tool tests. We're looking at 3 different tools where measurements have been taken. They have recorded the measurement on each of the 3 axes of the measurement and then the average of the 3 axes. Each measurement has been taken 3 times over 1 minute and then combined to give an average of the test result. In presenting the data this way, there's almost a false sense of security that a very accurate process has been carried out here. And yet you can see within each result there's variability. And it should be recognised that these are just 3 1-minute instances of using this tool. And you still then have to be comfortable that the future use of this tool will reflect what you intend to use with the tool in the many ways that you might use that tool. So is this indeed an accurate assessment of these tools for the varied purposes that they may be used? Also, in doing this type of work, there's a tendency to cover all tools in the same way. But do you know that all of these tools are major contributors to your employees' risk? So you could be carrying out a lot of activity here, which is not necessarily helping you control the risk of your employees. Also, what this is doing is assessing the risk from each tool. So for each tool, we're being informed of the time to the action value, the time to the limit value, and again, the points per hour that you would receive from this tool, again shown in decimal places, which suggest an accuracy. But how do you then combine possible use of this tool in the future over varying lengths of time? So this may be something that informs future risk assessment, but this in itself is not a risk assessment. Rather, risk assessment methodologies need to consider the task. And there is a lot more to be gained from perhaps having a reasonable assessment of the activities than details of specific tools. By tool types and gaining an understanding of tool types, you can immediately categorize them into levels of risk depending on the order of magnitude that you tend to use that tool for. So a rotary tool used for more than an hour would carry medium risk, but more than 4 hours, you would be high risk. A much heavier tool, such as a percussive tool, that medium risk is more of the order of 15 minutes, and your high risk is achieved in just an hour. Time and motion studies or tracking tool activities will quickly allow you to gather a better understanding of where the risk is developing from. In the following slide, we'll look at data from one particularly detailed work study or timing motion study that was carried out by a utilities company. So the utilities company looked over a period of time at a number of people carrying out the same task. The task was to excavate a 1 meter squared hole, and this task was carried out repeatedly and measured repeatedly when using different teams of experienced individuals, all of them working with the same tool. And from that activity being measured several times over, it was possible to then establish what the typical time for excavation of the tool was and what the typical vibration magnitude was developed while doing that particular task. It was therefore possible to establish that to excavate the hole would generate something like a risk of 280 points. So a control measure for that employer was to ideally put 3 men to the task of excavating the hole at any one time, and that would reduce the risk to 90 points. If they were in a position where only 2 people were available for that excavation, then they would have the understanding that the risk level would be about 140 points for those people, and they could then think forward in terms of what they would next assign those people to do, given what they were likely to have exposed them to. Now, during this exercise, what was also established was how varied the actual risk to the individuals could be while carrying out this task. So the individuals were fitted with equipment that allowed their precise exposure to be measured through the course of this exercise. And the reason for sharing this is simply to show you the variability that comes into work following a risk assessment. So you can see the range from individuals being round about or below 50 points to the most exposed person being at 360 points. So this has to be borne in mind when you carry out a risk assessment, is understanding at the same time where your variables are and what the extent of those variables can be. And that was something that this duty holder was able to establish from such a detailed example. What that example very much points to as well is the need to consider the risk assessment of exposure to hand-arm vibration to be a fairly continuous process. For sure, your initial risk assessments should be of enough quality that allows you to know that you can put people to work within a level of understanding of what their safety level might be. It will also allow you to establish what an appropriate set of control measures should be for that work, and also determine if occupational health screening is required. But it is important that you continue to evaluate the validity of that risk assessment and monitor the activities of the individuals to ensure that your risk assessment was indeed appropriate, and there are tools and technologies that can help you carry out that type of work. It's important to check that your risk assessments remain valid, remain up to date to any changes that might happen in your processes and individuals, and also to make sure that your control measures are working and are keeping people at the desired risk levels. And it's only really in reviewing and checking on those controls that you can, in all honesty, say that you are working to reduce that risk as low as reasonably practical. Control measures are certainly important that they're put in place, but also checking that those control measures give you the appropriate output is really the end of the process, or that continuous process to reduce risk as low as reasonably practical. So in summary, in order to carry out a risk assessment of exposure to hand-arm vibration, you should identify where there might be a risk from vibration and who is likely to be affected. You should obtain a reasonable estimate of your employees' exposure, remembering that it will only be a reasonable estimate. But you should be confident that the vibration magnitude data used in your risk assessment is suitable or representative of the risk that is being evaluated, and should certainly not underestimate the risk. From this, you will be able to identify when controls are needed in order to comply with the law and what the nature of those controls should be. And you will also identify employees who will be in need of health surveillance. So that concludes this second webinar in the series of 5 on assessing hand-arm vibration risk. I'll leave you with a set of other reference material available from the HSE for further guidance.